Thanks, Malcolm. I'm pretty hopeless with microphones. So, can you hear me at the back, John? Okay, I'm going to try and live without the microphone because, as I say, I'm bad at it. I want to talk today about a couple of examples. In fact, Ian and I are doing what I think is a very good tag team effort here, because Ian's, I think, set the scene very well for the science policy interface and some of the issues. I want to give a couple of case studies. The first looking at connectivity, and the second looking at where we're at with monitoring the Great Barrier Reef zoning. Right. Is that the forward one? So I'm a partner investigator in the Centre of Excellence, and a big part of my role is trying to implement that science policy, science management transfer. And one of the things about ARC Centre of Excellence is that they like to really emphasise is the importance of partnerships, and the talk I'm going to give is a real classic demonstration, because it really is a collaboration with a very large number of scientists. I'll try and name them all in print at least, but also there's a very large amount of both information and ideas from a lot of people at the Marine Park Authority here. So I think Ian set the scene quite well. In the context of this talk, the context is not about the science. The context is actually about the Great Barrier Reef. It's a place of extraordinary ecological importance, social importance as an icon, economic importance, and it has extraordinary beauty. And maintaining those values is the context for this talk and for really the challenge before us. It's those values that lead to its status as a marine park and as a World Heritage Area. And it is those values that are the challenge of maintaining those values. So a couple of case studies. This is the outline for the talk. The first is actually about the planning phase of adaptive management. So, and it's really about identifying one particular aspect of resilience, the connectivity, and the kinds of ideas that Jeff Jones talked about yesterday, and what we can do about actually implementing those in management. The second example is taking a moment to look back 5 years on from the 2004 rezoning of the Great Barrier Reef and find out what we've learned so far. So you'll see that in both cases it's not really my own work, it's drawing on the work of other people and trying to take some lessons from it. So let's have a look at connectivity. A couple of years ago, when I did a bit of a look at the different factors that contribute to resilience, that science is telling us resilient coral reefs need, it struck me that quite a few of those are things that we at least know what to do about. Some of them, like the top one, are challenging to actually do it, but we know what we need to do. We need to have less carbon, we need to avoid overfishing, we need to not pollute waters and so on. But some of them are much more challenging to know what you actually need to do. Well, you need to protect connectivity between reefs and so on. Okay, but how? What do you actually do? So that's the challenge. Connectivity is an extremely complex field. We hear and think a lot about connectivity within a habitat type, between patches, for example, between coral reefs. But we also need to be considering connectivity between habitat reefs, coral reefs to mangroves and so on. We need to be thinking about connectivity within a reserve network, between reserves, but also between the network and non-reserve areas. We need to be thinking about all of the different dimensions and things like pelagic and benthic couplings, land-sea couplings, etc. That's a tremendous paper by Mike Capo and Russell Kelly. The key point here, and this ties very strongly to what Ian was saying, is that in terms of all of these things, almost all of them, even for the Great Barrier Reef, are really largely unknown, and certainly in practically every case, even if we were trying to do clownfish between reefs on the Great Barrier Reef, really don't have sufficient information to know exactly what we should do. So a couple of years ago, a year and a half ago, Jeff Jones and the ARC Centre's connectivity program and the Coral Reef Targeted Research Connectivity Program held a workshop where virtually all of the top scientists in the field came together to discuss the latest research. And as Jeff said yesterday, there's been some amazing developments in that field in the last 10 years or so. But I put the challenge to that group of scientists to answer that question: what do we actually do about managing connectivity? And this paper was the outcome of that discussion. Fundamentally, what we agreed uncertainty, the kind of lack of knowledge that Ian was referring to, we need a set of rules of thumb or guidelines, principle-based management rather than specific knowledge. It's important to emphasise that the stuff I'm going to tell you here is I'm not pretending it's a major scientific breakthrough, unlike the work that people like Jeff and Simon are doing. What it does is it consolidates the best current knowledge into a set of how-to instructions so that managers can actually take that set of how-to instructions and try and implement them. So we came up with a set of principles. There were general examples and specific examples. Fundamentally, it comes down to three things. Good conservation, good marine conservation practice as we already knew it. That's important. We need to incorporate inter-reserve distances. I'll come back to that. And we need to be dealing with communication and community engagement. Let's have a look at those in a little more detail, just quickly. There are, as I said, there are broad principles and specific guidelines. We need to allow margins of error in both the extent and the nature of protection. And that's whether it's a marine reserve network or a water quality program or a climate change program. We need margins of error as insurance against unforeseen events or incomplete and misunderstood threats and so on. We need to be spreading risk. We need to aim for networks of protected areas which are comprehensive and spread, which are adequate, which are representative, and ideally replicated. We need to be protecting entire biological units where we can, and where we can't to be just going for big areas. So far, what we've really been talking about is things that have already been out there. They were fundamental to the work that people like Leanne and John did on the rezoning of the Great Barrier Reef, and so on. Here's one new point, the incorporation of dispersal distances. We'll have a look at that in a second. But the other point that always needs to be made is it's not just about reserve systems, it needs to be part of a portfolio of approaches, and I'll come back to that in the second part of the talk. Let's have a look at dispersal distances for a moment. So Jeff said a number of, well, one of the recommendations that this team of scientists came up with is that we need to be actually maintaining a range of dispersal distances and not just targeting specific narrow windows. So this graph shows you for a range of distances from 0 to 2 kilometres out to about 30 or 40 kilometres, the frequency distributions of, for every reef on the Great Barrier Reef, that's the black bars, the first one, for every reef, where is its nearest neighbour that could act as a source of clownfish larvae or coral larvae or coral trout larvae or so on after a disturbance or just to resupply the population. You can see that a very large number of them are all within 10 kilometres or so. The second bar here, the green bars, shows you the distribution of inter-reef distance or nearest neighbour distances for the no-take reserve network on the Great Barrier Reef. And you can see that it actually matches the black bars very, very closely. Now what that basically says is that the no-take reserve on the Great Barrier Reef closely matches the dispersal distance distribution for the natural system on the Great Barrier Reef. And it's worth pointing out that this is not actually a designed-in feature in the case of the Great Barrier Reef. It's actually an outcome of those other good conservation practices. Connectivity was taken into account, but it was not deliberately included to aim to match that frequency distribution. The other thing that the scientists are telling us, particularly Jeff mentioned yesterday, that we need to be looking at having a lot of reserves within 15 to 30 kilometres of a potential source reef. And when we look at that for the Great Barrier Reef, we see that again we've done a very good job of achieving that outcome for both the no-take networks, but the key point that I want to make in this context is this final set of bars here, the pale blue or the transparent blue. That actually indicates the nearest neighbour distances for all of the fished reef on the Great Barrier Reef, the nearest no-take reef. In other words, what is the capacity for fished reefs on the Great Barrier Reef to obtain propagules from the no-take marine reserve network? And the capacity is very good. It's about 90% from there. So what that's saying is that the no-take reserve on the Great Barrier Reef has a lot of capacity to resupply fished areas on the Great Barrier Reef. Keep going for the computer and there isn't one. Okay, the final point to make here, I that connectivity is a little different to some of the issues we deal with in terms of public understanding. The public can understand fairly simply whether or not they agree about the importance of pollution or the importance of overfishing and so on. Connectivity is a much more difficult concept, especially for people whose lives are terrestrially based. And this, John Day always makes the point, John's at the Marine Park Authority, that this poster by Russell Kelly was really pivotal in allowing the broader public in the GBR catchment to engage with the whole issue of connectivity. I'm clearly triggering a lot of things for Leanne here. Okay, so I want to move on now to the second part of the Marine Park, the second part of this talk, and that is looking at the network of no-take zones on the Great Barrier Reef and what monitoring has told us to date. So the rest of this talk is blatant plagiarism. I'm bringing together a whole bunch of other people's work, but work with which I like to think I've been involved. A whole bunch of other people, enormous number of co-authors. I'm not going to read them to you. What I do want to do is emphasise the significance of the Great Barrier Reef Network as a case study, and that's a scientific significance, the science of adaptive management of marine reserves. It's significant because of its extraordinary size and the global scheme of things, because of the replication that size allowed us and good design led to, the capacity to support or some before-after comparisons, the importance of no entry zones I'll come back to later, but also the fact that it was the first really large-scale comprehensive application of the kinds of conservation principles that we often talk about. One thing that emerged as I did this review was that there was actually a lot more information out there than many of us realised when you bring it all together. I also want to point out that I'm not going to address aspects of process, the importance of governance and community engagement, participation and so on. Those things are fundamentally important, but they're not part of my talk today. Okay, another point that's really important to emphasise is that a marine reserve network is a fundamental component of effective ecosystem-based management, but it is only one component of an integrated package. And just to illustrate that and to emphasise it, this is a range of other management strategies that are used on the Great Barrier Reef in concert with the Marine Protected Area Network. Okay, but moving on to the 2004 zoning. Many of you will be familiar with the international recognition that's been given to this figure here, which is that approximately a third of the entire marine park is now in no-take areas. But I think there's a couple of other much more significant factors. The first is that that 1/3, in fact, is composed of at least 20% of every single bioregion in the ecosystem being protected in highly protected zones. And the other is this figure here, which is that when you add that figure and that figure, you get approximately 2/3 of the marine park is now closed to trawling or any other form of habitat-destructive fishing. And that's extremely significant. Okay, so let's have a look at some of the results for the monitoring that are emerging. The first is monitoring of target fish. This particular graph is from Dave Rich Evans and Gary Russell's work. We've seen it a number of times, but basically what it shows is that since the zoning in 2004, there's been marked increases in the numbers and the biomass of coral trout. And when we look at a range, sorry, this is not showing up well, is it? A range of latitudes and a range of cross-shelf positions, inshore to offshore, we see very similar patterns emerging throughout the inshore, again, steady increases in biomass, and on the offshore reefs. And I'll just point out that the time points on these graphs are different. This is before-after comparison. This is 2006 to 2008. So this is new data that Hugh's just given me from the AIMS Long-Term Monitoring Program, and you can see that in general, the differences are persisting in time. They seem to be steady, whilst highly dynamic. Okay, there's now quite a widespread range of other similar data. This is some monitoring by the guys at AIMS looking at the seabed shoals, a very different ecosystem to coral reefs. There are some exceptions, but in general we're seeing larger numbers of target fish on the shoals. We're seeing long-term differences. This is some pre-2004 zoning monitoring from Dave Williamson, where we're seeing the differences persisting. This is from the effects of line fishing experiment. Again, the former zoning scheme. Again, we're seeing consistently, oh, guess what? You know, if you stop fishing in an area, you get more fish. Who'd have thought? But, and as Terry Harper mentioned, this is a very important result. It's very important that we put those, good Lord, you're up already. We put those no-take comparisons in the broader context of the results from no-entry reefs. And what we see is on no-entry reefs, we see some very important, we see that the abundances of both target fish and sharks are much higher. So this is the word Sean referred to. That has a couple of really important consequences. Firstly, as Terry indicated, it raises a very real issue about compliance within the no-take areas. But from a biological management point of view, it also raises the idea that we have depleted stocks of both sharks and target fish throughout, in fact, the majority of the area of the Great Barrier Reef, because this is 1/3 of the coral reefs, and this is about 2/3 of the coral reefs. So we're looking at about half to, well, about a quarter or so, the natural levels of stocks. That's a very important point. Why is it important? It's important because it can have ecological consequences as well as consequences for fish stocks. This is some recent work done by Hugh Sweetman. I'm going to have to rush, so I apologise, but we're looking at the proportion of reefs which have suffered from crown thorns outbreaks in fished and no-take reefs. And you can see that fished reefs have a much higher proportion of outtakes. There's some issues about how many reefs are available for that comparison. But this is some new data that Hugh and I just worked out recently, which looked at for reefs which have recently been struck by crown of thorn starfish, or sorry, reefs in regions which have recently had crown of thorn starfish outbreaks. What's the CoralCoE? And you can see that the no-take reefs actually have significantly higher CoralCoE. That's quite an important result because it's suggesting, for the first time, it's showing us that no-take zones appear to benefit, sorry, it's not exactly the first time, benefit coral abundance, the very basis of the ecosystem. And these are not things, obviously coral is not directly managed by the zoning. I'm going to have to skip forward. So basically, dugong are a large mobile species which operate at larger scales than the no-take areas. Zoning has, Elena Dresch and Helene Marsh have done a risk assessment study which suggests that zoning is very beneficial in those kind of circumstances, but it's not sufficient. We heard a lot before the 2004 zoning about the risk to the recreational fishing-based businesses in the catchment of the Great Barrier Reef. So this graph shows you the registrations of recreational vessels up to the 2004 zoning and after the 2004 zoning. You can see the enormous impact that you experienced in that particular circumstance. Steve Sutton has done some social surveys showing that of recreational fishers, one of the groups most affected by the zoning, we have strong support. Okay, this is second last slide. Many of you will have heard, so let's try and put this in a bit of an economic and financial context. Many of you will have heard this figure that we tout that the Great Barrier Reef brings in $5.5 billion to the Australian economy on an annual basis. That's from Access Economics, and employs about 54,000 people. But what I want to show you is that when you put together the compilations of that, that amount is increasing, and it's largely increasing because of a steady increase in the tourism proportion of that. It's worth noting that tourism is by far the largest proportion. What I also want to do, though, is compare the income from the Great Barrier Reef with what we spend on the Great Barrier Reef. Now, that's those bars there, and they're not going to appear, they're already there. We spend approximately 0.3% as a proportion of what the Great Barrier Reef brings on enforcement, or 0.9% and decreasing on the entire Great Barrier Reef Marine Park Authority and associated costs. So let's have a look at those in a little more detail, because you'll recall in 2004 we increased no-take areas by approximately 5 or 6-fold. Was there a proportional increase minor increase in both enforcement and the overall cost of management, but it was not anything like proportional to the increase in no-take areas. Even when you factor in the cost of the structural adjustment package of approximately $211 million, it still only constitutes about 6% of 1 year's revenue from the marine park. Okay, so take-home messages. Sorry, Malcolm. Science to management. Ian made all of the key points there for me, so thanks, Ian. The approach of dealing with imperfect knowledge by having a set of general principles, such as those that people like Leanne and John developed for the zoning, can lead to some very good outcomes. We're seeing benefits for fish stocks, for shark stocks, and even for corals, the building blocks of coral reef resilience. But it's important to recognise that it's not the be-all and end-all. It's not sufficient for especially large, highly mobile, slow-reproducing species like sharks and dugong. The no-entry zones bring up some issues both of compliance but also of shifted baselines and depleted stocks across the entire system. Marine reserve networks do seem to be cost-effective if you consider the last slide. And I just point out that in an adaptive management context, we have a new mechanism on the Great Barrier Reef, the Outlook report, again Terry referred to, and I think David's going to discuss that in more